Hello and welcome to this podcast for Electropages. I'm your host, Robin Mitchell, and today I am joined by Duker Dapper from Flip Electronics.
Good morning, Robin.
And so in this episode, we're going to be looking at the new acquisition from Flip Electronics. Is that correct?
Yes.
So could you just give us a bit of background into Flip Electronics first before we get into the details of this acquisition?
Yeah, so Flip Electronics was started about 5 years ago as a company that would specialize in solving the EOL problem for end users of semiconductor products. So products that have been EOL'd by original component manufacturers, large IDMs or fabless semiconductor companies. Flip stepped into the market in an attempt to bridge that gap of the end user's product life cycle and the semiconductor product life cycle. So oftentimes the life cycles of the end user products are longer than the semiconductor life cycle. So The question is, how do you bridge that gap and continue to supply products over a longer period of time? And Flip approached it from a perspective of buying finished goods and buying products and holding those, storing those products in inventory, and then selling them back off over time as to, again, bridge that gap between the end user life cycle and the semiconductor life cycle. So that's how Flip got started. They've been very successful at it. They've got good reach in the industry in terms of acquiring product. They have good customer reach in terms of the end users. And as you can see from their financial results, they've been very successful with it.
And so does Flip Electronics, do you store both wafers and the chips, or is it just the chips themselves, like as a complete package?
Up to this point, they've been primarily purchasing packaged finished goods, and this is the value. One of the values that the Resurgent acquisition adds to Flip is that now we Flip and Resurgent combined can purchase wafers, and Resurgent has the knowledge, the know-how, and the industry contacts to then take those wafers and turn them into finished product and sell them into the marketplace. And this provides a number of advantages for Flip in that the cost of inventory is lower. Obviously, purchasing wafers versus purchasing finished product is less. Financial commitment by Flip is less. It allows Flip to therefore expand the number of products that it can continue to supply over a longer period of time. And it also offers more versatility for the end product. So oftentimes a single wafer will produce a number of different products, either different package die combinations, perhaps different bond outs. So you're getting multiple products from a single die. So now the versatility of the inventory is much larger also, and that benefits Flip. It also benefits the end customer, because if you've got a customer that, let's say there's 2 or 3 packages that are produced off that a single die goes into, obviously some of those are lower volume and some are higher volume. So typically Flip would just buy the high volume product and store that as finished goods. But with a die model, we can now produce those smaller volume packages and therefore satisfy a larger number of customers, and again bridge that gap between the semiconductor EOL, the semiconductor product life cycle, and the end user product life cycle.
And so to be clear, Flip Electronics historically dealt with finished goods and finished packages, whereas the new acquisition, Resurgent, is giving you the ability to store wafers to give customers more options.
Absolutely. And not only that, so the Resurgent model, let me further talk about the Resurgent model for a moment. Our business model is based, you can think about Resurgent Semiconductor as a fabless semiconductor company.
Right.
But the only difference between Resurgent and what you would typically think about as a fabless semiconductor company is we don't design our own products. Our products come to us via manufacturing license agreements from original component manufacturers. So we acquire those licensing rights, and then we go out and we build the products. So we have foundry relationships. You know, we build wafers right now via foundries. So we can build wafers, we can assemble them, we can test them, and we ship them. So we can continue to manufacture the product over a longer period of time. Even if we don't have a die supply, we can continue to manufacture from the foundry. So this again gives Flip another arrow in its quiver, so to speak, in how we solve the problems of the EOL problem for the end users over a longer period of time.
That's quite interesting because we've seen other businesses who store the wafers, the spare wafers from the factory for long-term storage when those parts become needed in the future. But you're saying that that the Resurgent, what it's doing is actually taking the IP from companies who no longer want to manufacture that part, then giving you the right to then remake those goods. So when people require a part that's no longer in production from the original manufacturer, you can still provide them with a brand new chip that's just come off the production line.
That's correct. Exactly. And furthermore, what we do is as much as possible, we use exactly the same supply chain as the original component manufacturer, meaning we use the same foundry, it's the same mask sets, the same sort test program, the same assembly OSAT, the same test program, the same test hardware. If you take a Resurgent manufactured part and a part built by the OCM, there's electrically, physically, no difference. The only difference you'll see is if the package is large enough, we put a Resurgent brand on it versus the OCM brand. We even use the same part number. We get permission from the OCMs to use the same part number. So everything is identical. So what the purpose behind that, the value proposition behind that is that we want to minimize the amount of requalification that the end customer has to do. So they'll have to update their BOM to put a new manufacturer in, Resurgent Manufacturing Services. But other than that, the part should be indistinguishable. The data sheet's the same, quality levels are the same, and everything. So they can be assured that they're getting high quality 2 data sheet parts with codes.
Now, that brings me to a really interesting point because I would say one of the bigger challenges for engineers who are building products that require parts that are no longer manufactured is counterfeits and the grey market. You know, you find a supplier and you're not entirely sure if you can trust them because the part hasn't been manufactured for a good 10 years. And people like Flip Electronics and now the Resurgent allows engineers to basically solve that challenge.
Correct. Yeah. So you're guaranteed there's no counterfeits. As I mentioned, we Resurgent are for the quality of the part. If there's any quality issues, we take care of solving those issues. And this is this is an advantage for the OCMs is that they can completely wash their hands of the part. They don't have to worry about going back, 5 years later and dealing with a quality problem or dealing with a customer that wants more parts, etc. That's a low value add, high cost of resource type of problem for them to solve. And we eliminate all that on the OCM side. We take complete responsibility for quality. Everything you would think about that needs to be done to support the part over the long term, that's our responsibility.
Now, one interesting thing you mentioned was you said that you use the same manufacturer, the same foundry, the same processes. So that way the part that the customer receives is basically identical to the one they would have purchased maybe 10 or 20 years ago. But have you ever been in a situation where you find that a foundry shut down or it no longer has the necessary hardware to support manufacturing that product? And if so, what would you do?
So that's where I put the caveat as far as possible. If let's say that a foundry is shutting down a process, which happens often, then in that case, what we will do is purchase wafers and die bank them. So we'll basically do last time buy of wafers and we'll hold them and then we'll continue to build them out from there. So as you may or may not be aware, wafers, if stored properly, definitely last, or they last indefinitely. So you can store wafers for, I've built wafers that have been in storage for 10 years, 15 years. If they're stored properly, there's no corrosion on the pads, et cetera, those wafers are perfectly fine to build and their quality is fine. There's no issues. storing packages is a little bit different. Depending on the package, they may have a shelf life. So to answer your question, if a foundry is shutting down a process and we still see demand, then we'll do a last time buy of wafers, die bank the wafers, and then build out from there.
And I suppose the reason why packaged parts have more challenges is I suppose that the casing of the package might be susceptible to humidity, the pads might corrode, it's difficult to keep them clean. Is that the kind of issue you tend to find?
Yes, exactly. So with plastic in encapsulated packages, so classic lead frame packages, you got MSL situations, and those are fairly easy to store over the long term. You can rebake them and get the moisture out of them and bring them back. The packages that tend to be more difficult are the BGAs and organic substrates, where those, once they reach their shelf life, then you can sometimes bring them back, but they have a definitely a limited amount of time that they can be stored. So those packages present more of a problem where you've got organic components. If you've got underfills or FR4 substrates, those have a limited shelf life. Now it's 4 or 5 years, which is a long time on some horizons, but for other customers, that's not as long a horizon.
Yeah. So one question I've got about Resurgent is that it shows a sort of like a direction on product, and it seems to show a lot of high-end amplifiers. Is that the case? Is it like directed towards amplifiers, or is it just sort of any generic product?
So they're primarily high-performance op amps. This was a line that we picked up from Max Linear. It's the old Kadeka high-performance op amp line. And so, yes, these are products that were manufactured, well, let me rephrase that. They were designed probably 20 years ago.
Right.
Most of the wafers were literally manufactured 10 to 15 years ago, because most of these wafers were built at Plessey fab, which has now long been shut down. So that's a case where we're storing the wafers. The wafers are stored at our assembly and test location in Taiwan. Those wafers are literally 10 years old, and we continue to build them and sell product. And they're perfectly fine.
That would be an example, wouldn't it? For the fact that, as we mentioned, if a fab facility shuts down, you can't just go back to the same place to get them made. And the interesting thing as well is that, if you're using wafers, I don't know how many dies you get on one of those wafers. How many would you reckon? In the thousands, tens of thousands?
So depending on for the op amps, they're between 16 to 25,000 die per
on
wafer.
A single die.
These are small chips.
Yeah, that's a lot.
Huge amount of die. So the wafers last a long time.
Yeah, and
so you buy a lot of wafers,
and so you only have to buy maybe a couple of hundred, and then you've got yourself a couple of million of amplifiers already there. And I suppose that in terms of storage as well, you can stack them in those. I've seen them before. There's orange cases which the dies come in, the wafers come in, and I imagine they're more easily controlled for humidity and the environmental controls as well.
Exactly. You store them in wafer jars in a nitrogen purge cabinet in a controlled temperature environment, and they're fine.
Yeah, that's absolutely fantastic. So are there any other details you can tell us about the new acquisition from Flip Electronics?
Well, so we brought over the products that we have, and we're continuing to work with Flip on on new opportunities. So we've got a number of things in the pipeline right now. It's pretty straightforward transaction. I guess there's not a lot to say about it, other than we're now part of Flip. We add to their, as we discussed, we've added to their capabilities and their breadth of solutions for solving this problem of EOL.
And so Flip Electronics has given you would you say that Flip Electronics has given you that sort of like distributor angle that Resurgent can now use?
Right. So I should say, so we're a wholly owned subsidiary of Flip Electronics. And what we get is one of the biggest values for Resurgent out of this is that we've got a much broader reach now, the OCM. So we've got 30, 35, 40 people on the street, right? Talking to OCMs, talking to end customers. And our opportunities for Resurgent come both from end customers and from OEMs. So we've got a situation we're working on right now where an OCM a package was EOL, BGA substrate was EOL by by the manufacturer of the substrate. And this is an older product line, so it's not a lot of volume. So the OCM decided just to EOL it. Well, this particular product is used in some military and not aerospace, but avionics applications that have a very long lifetime. And of course, they're not happy about having to try and redesign their system to accommodate a new part because they got to go through, they've got to go through a long qualification, et cetera. So we are right now working with a smaller company, a smaller supplier of substrates to redesign that substrate and recreate that package and continue to produce the part. And so this is an opportunity that we wouldn't have seen we Resurgent wouldn't have seen on our own because we just don't have that type of reach. So we Resurgent are able to have a much broader reach in the market where, there's a lot of opportunities. As you're aware, there's just multiple instances where people being end users are crying for parts and they are looking for a long-term solution. And our solution really benefits both the OCM and the end user. So we try to offer a win-win-win, win for the OCM, win for the customer, and win for us in terms of the solutions we provide.
I should have asked this question at the very beginning, but what's the biggest challenge that you see engineers facing in this field of obsolescence?
Yeah, I think that the biggest challenge is that they'll see an OCM for whatever reason, and I won't name names, but they will EOL a part and give the end users 30 days to get a last time buy and maybe and in some instances 60 days for last time ships. And there's just no way that an end user can make any design changes or really do any planning. I mean, in that amount of time, they can probably barely figure out what their last time buy need is.
So you're saying there are situations where an engineer will be faced with a 30-day notice for a part to go end of line?
Yeah, it happens. And I will say it's not the normal course of business, but it happens.
That's shocking.
If the OCM is surprised for some reason, it was happening quite a bit actually in 21 and 22 when there was a huge squeeze, a huge supply shortage of semiconductors because foundries, assembly and test houses wanted to dedicate their available capacity to their higher volume, more profitable products. Yeah. And in one case, I know a foundry just EOL'd the process and said, I'm going to do I think it was something on the order of 6 months for last time buys and 12 months for last time ships. Well, that's highly unusual for a foundry in terms of EOL a process. Typically, that would be 12 and 24 months at the least, and sometimes 24 and 6 when they're EOL in a process. But again, it was an unusual circumstance, and I know at least 2 instances of where foundries just shut down processes and people were left hanging. And you were left hanging because there were no more wafers to be had. There was nothing that could be done. So it does happen. So that's a big problem, is trying to figure out what your strategy is going to be in the amount of time that you have before the last time buy-in. And then, of course, as an end user, that strategy, are you going to continue with the part and try and do a last time buy? Are you going to try and redesign your product to accommodate a new part? and therefore you've got to do a requalification. There's a lot of financial analysis. There's a lot of planning in terms of resource planning that has to be done to answer those questions. And so it takes, what it does is, I'll say it throws a wrench into the gears of the end user's, product development process, because now they've got to take engineers from their new product development and go and figure out how they're going to support this older part, which in many cases is still generating revenue. Their customers want it. The end customers still want to use the part. And so it's a big problem, because, then you've got to say, okay, are we going to delay our new product X to try and redesign old product Y, or are we going to EOL our old product Y? So it causes a lot of churn and a lot of turmoil at end users.
I'm just quite shocked that that foundries and those who are producing parts have the ability to do that in the first place. I would have thought you'd have to give the engineering industry, some kind of warning or some kind of better notice, because if you're a semiconductor manufacturer and your part is quite crucial to a number of commercial designs, and you suddenly go, right, I'm not going to make it anymore. Like you say, that can make or break. That has the potential to make or break a business.
Oh, there's no question. I mean, I speak of this because I was doing some consulting work for a major network hardware manufacturer in Silicon Valley, and I know of at least two instances where major foundries just killed processes, and the parts were gone. And the parts were going to be gone, and this network hardware manufacturer, there's, networking hardware is one of those classic industries where the same routers are still being used that were designed 10 years ago. Yeah. Because, if you're an Amazon or a Google or Facebook and you've got this huge installed base of these routers, well, you don't want to change everything in your network infrastructure to put a new router, a new different router architecture in. There's a huge barrier to doing that. Now, there are upgrades that happen, but there also are existing networks that are still to be built out. Anyways, the lifetime of those networking products is often much longer than the lifetime of the semiconductors that are going onto the boards. Yeah. And there was a 16 nanometer process that was just wiped out overnight, and the OCM that was supplying the part was in a jam, because obviously the networking company is going to the semiconductor manufacturer saying, hey, this is your problem, you got to solve it. And then they're putting pressure on them. And anyhow, it creates, like I say, it creates a lot of turmoil. There's a lot of energy that gets spent on it. And in a sense, I'll call it, it's kind of wasted energy, because there's no new value being created. You're just trying to keep an old product running.
Exactly. Yeah, and it makes me wonder do you think there could be a potential business for Flip Electronics and Resurgent in the future, where smaller engineering companies who might have a more niche product that's very sensitive to this kind of impact could consult Flip Electronics and say, we have a very sensitive product, we haven't got too much funds, but we're desperate to get a few wafers? Is that something that you think you guys could actually, almost like providing a type of insurance to products in the future?
So the answer is yes. I mean, that's exactly where we'd be able to step in and say, okay, we'll in fact, we're working on with a customer right now in a similar situation. They have designed ASICs through a third-party manufacturer, an ASIC supplier. In this case, the ASIC supplier controls their own wafer fab. So they're an IDM also who supplies ASICs. So they have the complete manufacturing infrastructure in place. Anyhow, the problem for the end customer is that exactly what you say, one lot will last them 10 years of supply. Yeah. And the supplier of the ASIC wants them to purchase at least 2 lots a year for every product. Well, if they do that, they're going to have 100 years of supply, after a couple of years. they don't want to do that. So the question is, how do they solve that problem? And that's what we're trying to work out the financial arrangements right now of, okay, we'll buy the wafers, we'll hold the wafers, and then we'll build them out for you over time. And we'll take so then you, Mr. End Customer, you don't have to hold the inventory on your books, which is their primary issue. We'll hold the inventory for you, and then, we'll build it out and sell it back. So the answer that's a long answer to your question, which is yes, we can absolutely do that.
That's absolutely fantastic. And again, engineers who are watching this right now, if you've got yourself a product, and you know that one of your parts might become end of life, Flip Electronics could definitely be the path for you, because as you just suggested, you've suggested you've got finance options, and support sort of infrastructure in place to make sure that if there is a part that you need but you can't deal with all the wafers that are going to be requested, you can hold on to those.
Yes, no doubt. So that's exactly one of these supply issues that we are ready to solve and we can solve. And that is another big advantage that Flip adds to Resurgent is the financial resources behind Flip. So we now, as a smaller company, we were not, Resurgent Semiconductor was not able to do these types of wafer buys and hold the wafers now. But with Flip, we now have more financial leverage, and we can do that. So it broadens our Resurgent's reach. Resurgent Manufacturing Services now broadens our capability to solve these problems.
Fantastic. So could you give us a quick rundown of the distributors that you've worked with in the past?
So we've worked with Arrow Electronics. They were a major global distributor for us. And then we also worked with a number of regional distributors in China, ZLG Technology, Teampo Technology, Baoli Technology. These are all smaller regional distributors in China. So it turns out that a lot of the amplifiers that we discussed earlier are sold in China. And then, so those regional distributors have a lot of reach in China, and they've been very successful for us in continuing to sell those amplifiers. So that's again a situation where they were selling the amplifiers for XR and Kodeka, and then we picked them up and we continued the relationship and continue to make and sell the product. Arrow has been distributing both the amplifiers and the MPR 121 QR2, which is a touch sense controller, for us from the beginning. So they were the first distributor we brought on. We will continue to have a relationship with them and sell product with Arrow going forward.
Is that the many distributors you've got in China? Is that to do with the fact that China as a country is a major manufacturing power, and is that why a lot of them are located there?
Yes. One, because they do a lot of manufacturing there, and two, they have a need for these products. So again, I think a lot of their customers are some of the smaller manufacturers in China. Right. And so when these smaller guys go to TI or ADI, to get an op amp, and especially in 2 years ago when there was a squeeze on everything, they couldn't get the time of day from these larger manufacturers. But our product is completely pin-to-pin and electrically compatible, so they come to us and we can deliver in 6 weeks.
And was some of those challenges also related to the semiconductor war between the West and China as well?
We haven't been hit by that too much because, we're talking about smaller, relatively low, old technology parts. And so it's not like we're selling graphics processors, 5 nanometer graphics processors or anything like that. So I would say we're not under the radar. We're just out of the scope of where that war is. And the other thing is that all of our manufacturing, we manufacture at TSMC, we assemble at Great Tech Electronics in Taiwan and at Carsem in Malaysia. So from one standpoint, the product doesn't look like it's coming from the U.S. at all. So it's got a origin of Taiwan or Malaysia. So,
But no, it is interesting though how because I do appreciate that it's mainly the high tech semiconductor markets that have been hit by the embargoes and the trade restrictions. But I wondered if even like certain obsolete components, because you did mention previously about military grade stuff, and I know that the military have a lot of issues with trying to get end of life products, and so I wondered whether even 10-year-old military equipment or military grade semiconductors are also, problematic when it comes to this current political situation.
I have to plead mea culpa, I guess, on that, because we haven't tried to do any of that.
Right.
We're just now kind of getting into the military and aerospace business, and so my experience in terms of actually trying to export those kind of parts is zero.
Fair enough.
But I would imagine that you would run into that run into that problem. So again, like I said, the parts we build, we're not high on the, we're not a big blip on the radar screen for government in terms of the trade war. So
and that's primarily because the components you focus on are the obsolete ones that you can no longer get, and if you try and get on the grey market, it could give you some serious issues.
Correct.
Well, that was an absolutely fantastic interview. Thank you ever so much for joining us on this podcast.
You bet. Thank you for having me, Robin. My pleasure to help out.